So specifically, the question is, if I have landmark points 1, 2, 3, 4, 5, how do I reverse the order of those points? So I'll just do an example really quick for that. So we've got landmark points picked up here, and so I'm holding down Shift, and I'm going to place those points on the surface. So I've got 5 points here, and to change the order of them, I want to go switch to the landmarks tab. Now I've got the points here. It may not be very clear, so if I click on the first point there, so the point 1 is the default name that's provided, that check1 provides. And if I move that around, sort of that name changes. But you can see this value over here, 1, stays the same. So this is like our internal indexing for the point, and then the point 1, 2, 3, 4 is kind of a default name assigned to it. So I'm gonna rename these just to make it a little bit clearer. A, B, C, D, E. And now if I move this point down, you can see that I'm changing the order of that. So if I wanted to reverse the points, I could just do this. A, B, C, D, E. So that's how you would reverse the points there. So that should answer that second question. So I'm actually gonna, so I'm gonna delete these. Let me go back and show some of the basic landmarking capabilities that we have. So this is not a bad specimen to try these on. So these are the basic landmarking capabilities that we have up here. We have single point primitives, and so single point, this is very much, you know, the same as the microscribe concept back there, where you have your specimen and you can place individual points across your specimen and then work with these points. So once it's there, you can click on it, move it around. You can look at where that point lies on the surface. This is where your volumetric data can be more helpful, because if I have a scan like this and I'm placing points on my surface here, I can go into the volumetric data and I can see maybe more precisely where that point lies on that surface, for example. So depending upon where you set your brightness and contrast, I can also change, you know, how the point. So here I moved it off the surface, so it's out, you know, hanging out in space here. So if I look at it from 3D, it's off in space. I can grab it, so I'm going to grab it and I can select it. I can't drag it around because there's no surface behind or underneath the mouse position, if you think of that. So I'm going to move it here. If I grab it here and then start moving it, it snaps back to the surface. So that's single points. You can also do a curve. So let's say we want to put a curve along here. Click that. We can just do this. 3. So I did 3 control points in this direction. And then you can see there's these little blue points that are made in between here. So if I grab these points and move them around, so these points with the arrows are the control points for the curve. So it makes a Bezier curve through the control points, and then it automatically generates. So the Bezier curve is shown by this little red line here, and then it automatically generates the semi-landmark points along there. So if I turn these off, you can see that there's points on the surface where I place those big arrows. So it generates the points along that red curve, and then it snaps them to the surface. So the original point was semi-landmark point was generated on this red curve up here, and then it gets snapped to the surface so that the points lie on the surface. It's a key thing. You're trying to measure your specimen, not some strange mathematical function. So you want it to be projected back to the surface. Another cool thing you can do is change the density of the semi-landmark sampling. So if I go and select curves, I can select my curve. Let's zoom in so we can see it. So there's my curve there. The surface is turned off. I can turn the surface on so you can see it. And then I can change the density of this. So this is the number of landmarks across the whole curve. And the numbers that are shown here are constructed such that you always have a point on the control points where you placed it. So it may seem like it's not very flexible in providing you certain numbers, but it's guaranteeing when you pick any of these values that you always get a point where you place these, and then it samples the same number of points in between these segments. So we have one segment here, 2, 3 segments in between the points that we placed, and so there's going to be the same number of points sampled between these. So this is the minimum. So the minimum is just no points, no semi-landmark points sampled between there. We just have our control points. And then this is one level up. So now we have one additional point in the middle, and so on. So that's where these values come from. So it guarantees that you have the same number of points within each segment. And then it projects those points down onto the surface. So depending upon the surface detail that you want, you can pick a bunch of points. We do put a maximum. Who would be crazy enough to use more points than that? That's a way to do that.
David, in regards to this, is there a way to flip the direction of the curve and actually change the ordering?
Yeah, you guys can do that too. So that's, it's this, yeah. So I have this one selected, and then you do this. So the reason you do that is it changes the order of the sequence of points when you're exporting. So if we do it in this direction, and then we look at the order of the points and how they're exported, that's what this is here. These are all the semi-landmark points that are being exported. From specimen to specimen, if you're just manually placing the points, it's easy often to put the points in the wrong order. So if you do that, this is a way to make sure that the primitives are ordered in the proper direction. If one of these semi-landmark points falls on, a hole, so if paleontologists are looking at some fossil and there's a whole piece that's broken off, excuse me, you can mark the individual points as missing. So in this case, you can see here, this little thing is allowing me to, walk through these semi-landmark points, and then I can mark that point as missing. If that makes sense. So missing would be the data literally is not there. And that's important when you're doing statistical analysis across these different things. Similarly with single points, if a particular point falls onto a piece of surface that is missing, you would mark that as missing. So there's still a representation of the point, but its actual coordinate doesn't have any meaning, if that makes sense. And so if you're doing generalized percussive analysis or something like that, you basically take that point out of that computation. Let's go back to here. Okay, this is fine. So that's curves. Then you can also do patches.